What's your question? Yeah, let me write good fast in a second. Yes, ma'am.
Well, she leaves, what
Figure it out. I'll move you to a different group.
Thank you. Because she will be girls. Are you okay? He says in the way he is.
Terrence? Yeah. Here. Alright. So let's have a quick discussion about some questions, statistical versus non-statistical, categorical versus numerical. This first question up here is actually one that I definitely wanted. Now, hey, focus and pay attention so you can learn something. Couple of quick things I want to make a note of in this setting, alright, is one, let me check something really quickly. So I have 17 people who responded to these bell ringers, at least on this one. On this one I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, okay, 17 again. And 5, 7, only 11 here. The bell ringers are something to get you started, but also to give us a chance to try something and to learn if you're making mistakes, okay? Which means I need y'all to take these seriously. If you choose to, if some of us choose to continue not doing the bell ringers or getting started on them quickly, I will start doing them as a grade. But not in the fun like, hey, did you do it kind of grade, a grade for accuracy. I assume you don't want bell ringers for accuracy. No, because we miss them a lot of times, right? So we as a class need to collectively say, we're going to start taking this seriously. This is for your learning. If you don't participate in these things, it's really hard for you to figure out if you understand it or not. Alright? So I need you to get seated and get to work right away so that we're ready when it's time to rock and roll. Are we clear on that? Okay. So, really quickly, in Mr. Kinney's class, what is your favorite number? Alright? Is that an overall question or a survey question?
A survey?
How do you know it's a survey?
Overall.
It's an overall?
Yes.
That's a person.
It is talking about a person. Remember, a survey question is the question that you're going to go up to a person to ask to figure out some other question. Are you going to ask that question directly to a single person? Yes. That's a survey question. We need to learn from that. If you are saying, hey, what is your blank? What is your height? What is your weight? What is your eye color? What is your favorite number? Those are all survey questions being directly asked to somebody. We don't want survey questions here. Rose, are you paying attention? Doesn't look like it. I need your eyes up here. Then, this is actually a really good thing to note here. In Mr. Kinney's class, what is your favorite number? Yes, you will get a number out of this. However, when I say numerical data, this is a detail that came up with my 11th and 12th graders in Algebra 2, because I did statistical questions versus non-statistical questions with them as well. I started to realize I need to be more clear about this. Numerical data, it's not always numerical data if it's a number. Alright? Me personally, what is my favorite number? You haven't studied it yet, but it's the number E. 2.718281828. It's kind of like pi, it's irrational. That is not a measurement. If someone were to come up to me and asked me, hey, Mr. Kenny, what is your weight? All right, I would respond with a measurement, a number, right? Somewhere around 200, 202 usually, okay? That's my weight. That is numerical data. That is something I can average. You're not going to average with my favorite number. You would count the frequency that people respond with that number. If you're counting the frequency that people respond with that thing, that's going to be a categorical data. I fit into the category of E is my favorite number. You could fit into the category that 5 is your favorite number. If you think about your cell phone number, are you ever going to average your cell phone number? By the way, Mari, it's 2. You're never going to average your cell phone number. The telephone area code for here is, 205, right? 205 is the area code for here. That fits you into the category of living in this part of the state of Alabama. Hillcrest High School, I think the zip code is 35401. Does that sound right?
No.
02?
35405.
35405, there we go. That is, even though it's a number, that fits you into the category of living in this area. Okay? So please understand, a number alone doesn't make it numerical data. Numerical data is usually something that we're measuring. Okay? So this idea of a favorite number, you're going to fit into a category for what your favorite number is. Does that distinction make sense? We good there? Okay, that's one of the reasons why I picked this question, or this question in general. Okay, so how many cars have you seen on the road today? Is that overall or is that a survey?
Overall.
That's overall. Or, whoa, sorry. It's what? That's a survey. I'm asking you how many you saw today. If I were to ask the question, in this classroom, what is a typical number of cars students saw today, then I would get information from each one of you and then probably add that, or average that number. That would be an overall question. This would be the survey question I would use to answer that question, but it has to be overall that we're talking about. Okay? What about this one? What number of students in this class have brown hair? Okay? Is that statistical?
No, that's category.
Well,
What?
is it
No.
statistical?
Just kidding, just kidding.
Raise your hand if you have brown hair in here. Okay, so I see 1, 2, 3, 4, 5, 6, 6 people. Okay? Hey, focus. 6 people, right? How many responses is that? 1. The response is there are 6 people with brown hair. So is that statistical?
Yeah.
Okay, what does it mean to be statistical? It has variability. Remember, non-statistical means it does not have variability. There's no variability in there. And then also, Kelsey, what were you about to say? That is what? Well, no, it'd still be numerical in that case. We could ask, yeah, that would not be categorical because it's already said brown hair, so I would number the people with brown hair. Okay, how many cows do you see on a farm usually? Is that going to be numerical?
Yeah.
Yes.
Okay, so if I go to one farm versus I go to another, will they have different numbers of cows?
Yeah.
Yeah.
Okay, so 2 different responses, right? So there's variability in the response, and I would count the number of cows to see how many they have. Could I average those number of cows? I mean, could I take the number from one place and the number from the other and average those? Yes. A good way to determine, hey, is it numerical is, can I average with that number, right?
So
I can average those number of cows, huh?
So that one, right?
Mm-hmm. The only thing I would add to that question is I would add a population. So what farms are you talking about? Are you talking about farms in Tuscaloosa? Talking about farms in Alabama? Talking about farms in the U.S.?
No, I'm talking about my granddad's farm.
Okay, so we do want to clarify that then, right? Notice it says how many cows do you see on a farm usually. If you're just talking about your granddaddy's farm, there's only that one farm, and so there's only one response.
He got 2 cows. That's why. But, I mean,
Okay, so I mean, if he has a different number of cows on each farm, then yes, you could make it statistical on that side of things. But if you were to say, hey, how many cows do, well, I guess, it also depends, if you were to say, do you see on a farm each day usually? Could you see a different number of cows each day?
You keep the same ones and this one just died, but you could.
But, I'm not saying, but the wording is, do you see? Do you see a different number each day? Oh, you see the same exact number every single day?
Don't
Okay.
worry.
Okay. If you were to ask the question though, then how many cows do farms in Tuscaloosa usually have? That would make it statistical then, right? Looking at every farm and then averaging the number of cows on those farms. Does that help clarify that? Okay. So you'd have to look at more than one place, not just one farm. Okay. Hopefully that helps. I know we didn't get to all of them. I'll try to get to several every now and then, more than one response. Alright, so 5, 3 is a solution to 3x minus 4y is greater than 7. Man, I had a lot of falses on that one.
Yeah, because it is.
Why is it false, Kelsey?
Because 5 is the x value and 3 is the y value. So substitute them.
Okay, so that 5 is taking the place of x.
Yeah.
Okay, and you say 3 is taking the place of y.
Yes.
Okay.
And 3 times 5 is 15. And 4 times 3 is 12. So 15 minus 12 is 3. And 3 is not greater than 7.
Okay, so Kelsey told me the procedures of what to do there. Hopefully that's kind of what most of us were thinking, that is a false statement. But why? What in the question told Kelsey to substitute 5, 3 into that inequality?
Is.
That is.
Solution.
Say it again, Josh.
Solution.
Solution. That's the key there. We're asking, we're saying that it is a solution, which if it's a solution, what does it have to do, Brandon? The what you call it. What is that what you call it? What do we call this thing? The alligator. No, sir. That's not what that is. Do we really not know the name of this?
The inequality.
Less than or equal to?
Inequality.
2 in a row.
You what?
I've been going by the alligator for the longest.
A lot of elementary school teachers teach students to call it an alligator because it can eat the bigger number, I think is where it comes from. But it's called an inequality, right? If I were to say x equals 5, I'm literally saying that x is the same as 5, right?
Yeah.
But if I were to say x is less than 5, that's what that symbol is. Okay, let me break it down this way. An equality, should have said this, means that they are equal, right? This is a prefix that means not. So it is literally saying that these things are not equal. Well, if x is less than 5, is it equal to 5? No. So they're called inequalities because it's any number less than 5. So 4, is that less than 5? 3.7, is that less than 5? Yes. What about -2, is that less than 5? Yes. Okay, so we want to recognize that it's called an inequality, but it's making the inequality true. Does that make sense? Good with that, Brendan? Inequality, not just whatchamacallit, inequality. Say it with me. What's it called?
Pac-Man.
What is it called? So, alright, so we gotta do it all together now because Brandon feels really uncomfortable. Alright, so on 3 as a class, what are we gonna say it's called? Inequality. So 1, 2, 3. Oh, that was lame. Alright, that was only half the class. We're gonna keep doing this until you all say it. 1, 2. Oh my gosh, that was even worse. Y'all are the worst. Oh, I have to say the 3?
Yes.
Okay. 1, 2, 3. Inequality. That's better. Alright, okay. So it's called inequality. Feel more comfortable now, Brandon? You were able to say it then? Did you say it then?
No, he didn't.
No.
Are you lying to me? We're gonna have to do it again?
No.
We gonna have to do it.
We gotta learn some math. Alright. So it's called an inequality, less than or greater than. There's also less than or equal to and greater than or equal to, but again, it did not make the inequality true, so that is a false statement. Alright, so
Zero.
we got more people to respond this time. That's exciting. I got 3 people who did say 0. I got 16 from 2 people, 48 from 2. I see.
Someone's at the door.
Come on, let's get ready for class.
That's not how you spell it.
Okay.
Is zero.
I got a 60 up here at 32. Okay, let's look at this one because they did show me their work. So they said 2x cubed minus 4 times 2 plus 2, or x plus 2. So how am I supposed to get started on this?
You gotta
Do the X bar.
Fill in the blank.
Substitute.
Okay. Jalen, what is more mathematically accurate than fill in the blanks?
Fill in the variable.
No.
Substitute.
Substitute. Jalen, what am I going to substitute in for x?
2.
The 2. Okay? So. Now I want to ask this because this is an important question. Are we supposed to do 2 times 2 first?
No.
Yeah.
Now you do two.
No, you gotta put parentheses around two.
Are there parentheses around the 2x?
No, but no.
No. So I'm not supposed to do 2 times 2 first. I'm supposed to do 2.
Times
To the
two
third.
times two times two.
Two.
So 2 to the third, right? Is there anything that I could do before I do 2 to the third? The 2 plus 2 in the parentheses, right? So be careful about that. So minus 4 times 4. Okay. What would be the next operation that I should probably do?
2/3.
Okay, so 2 to the third, or 2 cubed, which is 2 times 2 times 2, which is 8. Don't forget, you can use calculators to help you with that. You can literally type in 2 raised to the third. 2 times 8?
16.
16.
16.
4 times 4?
16.
16 minus 16?
0.
Ah. It looks like some of us might have forgotten the second part over here. That is way more that got it right than who got it right yesterday, so some of us are learning. Make sure you pay attention and learn from your mistakes.
This game.
What
Why you
else?
call it a cube?
What?
Why you call it a cube?
A cube?
Yeah.
Okay, you know x squared, right?
Yeah.
Do you know why it's called x squared?
No.
So if I were to try to find the area of a square, wouldn't I do x times x?
That was that from?
That's where that's from, okay? So notice the area of a square, x times x would be x squared. Where do you think x cubed comes from?
From a cube.
A cube.
Ew, that's
So if you have a cube, but now you'd be looking for the volume.
So base times height times width.
So base times width times height. That volume is equal to x cubed. That's where it's coming from.
Yeah.
It's just another, so like we only have special names for the square and for the cube,
But not further up.
but nothing else. No. Okay. All right, let's get to today's actual lesson. We're in geometry. You're not in algebra 2. All right, so let's get started with this agenda. Nope, come back. Okay, so we need to wrap up lesson 7, right? Acceptable moves to maintain equivalency before we get into lessons 8 and 9. Okay, you already have lesson 7, correct?
Yeah.
All right. Let's get that out. Let's go with Claire. Claire, can you read our first objective for us today?
I can explain why some algebraic moves create equivalent equations, but some do not.
Okay. So we looked at that pretty heavily yesterday. All right. In order to have, okay. in order to have equivalent equations, what has to be true?
Then,
They both have to be equal, but equal. Wait, what'd you ask?
In order to have equivalent equations, what has to be true?
Their solution has to be the same.
Okay, their solutions have to be the same. Partially true, mostly true, and I'll explain why it's not always true. Lenny, can you check that, please? Alright, so that is definitely a big part of it. Thanks, sir. What else has to be true about equivalent equations? Are those equivalent?
no.
Yeah.
No.
No, just kidding.
No.
Hurry up, no. Yeah.
I'm saying, yeah, they're the same numbers,
No.
but not the
Yes.
same,
They got the same variables, man.
not the same.
No.
Okay.
The
Let me
same
ask you this. If y is equal to 8, what's 5 plus 8?
13.
13? So in this case, m would equal 13. What's 13 minus 8?
They are equal. Yeah, I mean, yeah.
5.
They are.
So they look very different, right?
Yeah.
Because equivalent equations look different. But what? They're still the same. Those look very different. But are they telling the same story? If you think back to lesson 6, the difference between the middle child and the youngest child was how many years? 5. Which means that the middle child was equal to the younger child plus 5. Okay? So when I say what has to be true about equivalent equations, they need to look different, but they're still effectively the same. What can I use to create equivalent equations? I didn't use a number there. I used a variable there, but you don't always have to use variables. Okay, so on our lesson 7, we should have already written this down yesterday. Say it one more time. Say it louder.
Inequality.
See an inequality up here? No? There are 3 things we have talked about so far that create equivalent.
Distributive.
So one of those create equivalent equations. So we have the distributive property. We have a commutative property. So distributive property, commutative property. What else?
5 minutes.
Properties of equality. Guys, this is the most fundamental thing that I need you to understand.
Word.
Okay? You can use those sets of properties in order to create equivalent equalities or equations, right? Why can some algebraic moves create equivalent equations? Because we're using properties of equality, we're using commutative properties, things like that. Alright? And that relates very heavily to the equivalent, or to the steps of solving an equation. We're going to look at that a little bit today. Finally, we've got to know what it means for an equation to have no solutions and can recognize such an equation. So, all that being said, we looked at this yesterday, didn't we? This is where we wrapped up. I think if you took the right notes, we noted here that they used what property? That was the distributive property. Okay? To make the equations equivalent. What property here? Not substitution. Subtraction property. of equality. Anton, do you need to leave?
Yeah.
1220 or 220? Alright. So distributive property, subtraction property of equality. What about here?
I didn't do that, but.
He left
I
red.
think we divided by -3.
Oh, yeah.
He told you to get out or you leave.
What are you doing?
Listen.
Would you leave? Did you get your phone?
I'm gonna find that, bro.
Alright, go. Get out of here.
No.
So this would be, notice I did it to both sides of the equation. Alright, do we need to start to put our watch up too?
No, it's an emergency. My mama had to text me about something.
Okay. Division property of equality. What are we using for? As the left hand side is exactly the same. What happened on the right hand side? Guys, eyes up here.
Multiplication?
No. Because you don't have any of these notes written down there, so you should probably take some notes. It looks like these switched. They moved. They commuted, so the commutative property. And then here, we just simplified, right, to get that 4x, 3x plus x. So you have to do something like that in order for them to be equivalent. Nothing on the column B was equivalent. Nothing at all. So, why should we care about equivalent equations? We know how to create them now, hopefully, if we've been paying attention. But why does it matter?
It doesn't.
It doesn't at all. Okay, let me ask you this question. Just looking at that equation, does anyone know what the solution is?
Yeah, no,
Yeah, same. I don't either. I have no clue.
you just made it up.
I didn't. It's literally this on number 3.
Four.
It's definitely not a 4. Okay. What could I do to this equation? What have you learned to do in the past?
Then you
Divide,
inverse
subtract.
Okay, so divide, subtract, multiply. We could distribute. Personally, I see multiplication, so I'm going to
divide.
divide. What could I divide by?
-3.
What's -3 divided by -3?
One.
It's 1. Okay? Because 1 times 2x plus 9 is 2x plus 9. I need y'all to pay attention to this. Listen, all eyes up here. Austin, Terrence.
Where'd the one go?
Well, what's 1 times 5?
Oh, never mind, I got one, you did one. Oh, I got it.
Does that make sense?
Yeah.
Okay? So, is this orange equation easier to identify the solution than the original equation?
Yeah.
Yes. I still don't know it, but I do know that this is easier to work with.
Yeah.
True.
And I also know that this equation and the blue one are
Equivalent.
equivalent, so they have the same solution. Okay. Now what could I do to that equation?
Subtract.
Subtract how much?
-9.
I would probably subtract 9. I'm trying to get to this x here.
9.
Now notice, what's 9 minus 9?
0.
0. So 2x plus 0 is 2x. -4 minus 9 is. So, is that easier than the blue equation? Yes. Very much so, right?
Yes.
But this green equation is equivalent to the orange one, which is equivalent to the blue one. So all three of those have the same solution. What could I finally do from here?
Divide by 2.
So 2 divided by 2 is 1. X is equal to -6.5, or just, I'm okay with -13.5. Is this equation easier to identify the solution with? Yes, I literally have x equals -13.5. That's it. That's my solution. But I know this pink equation and the green equation are what?
Equivalent.
Equivalent, or the same, because I use the division property of equality. I know the green equation and the orange equation are equivalent because I use a subtraction property of equality. And I know the orange one and the blue one are equivalent because I used a division property of equality. The equivalence matters because if I can get an equation that has the same solution but is easier to work with, then I can find my solution. It matters. This is why I focus so heavily on equivalence. If you understand properties of equality and you understand distributive property and you understand the commutative property, you can make your job easier to solve for the solution. Does that make sense?
Yeah.
We good with that idea?
Yeah.
Okay. You have to remember which properties. That's why I keep harping on it. I know that some of y'all are like, Mr. Kenny, I'm tired of hearing this, but we keep forgetting to say, hey, are they equivalent so I can use distributive, commutative, or properties of equality. You got to look for that all the time in this class. All right? Here is where it gets a little interesting. If you remember the last objective, it said that we need to recognize when there is, in fact, no solution. Notice in this, I found a solution, x equals negative 13 halves. We good with that idea?
Yeah.
Yep. So, here in the third part of lesson 7, Noah is having trouble. By the way, I need all lines up here because yesterday was a fiasco for the first 5 to 10 minutes because no one knew what to do because we weren't paying attention when I went over directions. Let's make our job easier. Rose, if you want to go ahead and jump back to group 6, you can do that. Noah is having trouble solving 2 equations. In each case, he took steps that he thought were acceptable, but ended up with statements that are clearly not true. Look at the very end here. 6 equals 1.
No, it doesn't.
That is not a true statement, is it?
No.
Nope. 2 equals 3.
No.
Nope. Okay. So we need to notice he's ending up with statements that are clearly not true. Analyze Noah's work on each equation and the moves he made. Were they acceptable moves?
No.
Why do you think he ended up with a false equation? Right? So he ended up with a false equation. We got to figure out, is what he did okay or did he make a mistake somewhere? Discuss your observations with your group and be prepared to share your conclusions. If you get stuck, consider solving each equation. All right. Do we know what we're supposed to be doing?
Sir.
Let's get to work. That's not getting to work.
Cheerleaders.
Come on. Talk with each other.
We're gonna do this in the
Where's
dark.
your work? Where's your paper?
No, which one?
Lesson 7, the one we were working on yesterday. Do I need to turn on the lights so we can focus better? Lights
I have
on. Let's get to work. Hold on one second, let me turn off the camera. Come on, Alicia, get your head up.